You guys must have paid attention to the fact that we have tried to make future-proof interfaces multiple times, specifically after the advent of computers. And we have tried with USB, HDMI, DisplayPort, Ethernet, whatever have you. But we have always fallen short, and we always reach almost a brick wall where we can't make it any better. We end up adding more channels like PCI 2.0, basically USB 2.0 to 3.0. We added more cable conductors, and then again we went from 5 Gbps to 10 Gbps. Then we are like, yep, we reached another limit. Now we added more conductors, and then we reached 20 Gbps. Then we reached another limit. We did not wanted to add more conductors, so now we added retimer chips, because again frequencies were reaching such an absurd limit that copper could not carry it anymore. It literally requires basically full miniature computer in the USB-C port itself, so you can transmit 40 Gbps any reasonable distance. So why is that? Well, it is a fundamental principle of electricity itself, copper itself. Once you start to send high frequency signal, copper misbehaves, meaning you can send a very crisp square wave signal on one end. By the time it goes to, let's just say, 100 meter, it will become sine wave on its own. Basically, it will become distorted on its own. And not to mention the intensity. Let's say you are sending a signal from 0 volt to 3.3 volt. By the time it goes on the other end, it will drop to much lower level simply because of resistance. This sort of things do not occur in fiber. On top of that, fiber also has the ability that it does not care. Photon does not care with another photon, as in you can literally have multiple channels of data on one goddamn fiber strand, meaning nowadays it is normal to have 8 channels of transmission data and 8 channels of receiving data, all working for different things. And it's like fiber does not even care, meaning the fiber literally could be entrenched underground long ago, as in like in 90s, and they're like, hey, we changed the transceivers on both ends, now it's 1 Gbps. Hey, we changed the transceiver in 2010, so now it's 100 Gbps. Hey, we added multiplexer and duplexer into this puppy, now it's 400 Gbps. It is doable. Now, of course, fiber also has an upper limit. A, it could break. B, it could become opaque to certain wavelengths over time, but that happens through degradation and is a very slow process. So if we really want to create an interface that is long-term stable, we have to switch to fiber.